Hello everyone. In the previous class we have discussed Newton's first and second law of motion. Now in this video we are going to discuss the Newton's third law of motion. This is also a very important law, so you need to understand it very clearly. Now as per the statement, we can say that to every action there is an equal and opposite reaction. Here the terms action and reaction, this action here and the reaction you can see in the statement represents force. Now whenever there is an action, there will always be a reaction and both will act simultaneously. These are the two forces which acts simultaneously in opposite directions and their magnitude are also same. For example, let us take two bodies. Say one is given by A, another given by B, as you can see here. Now, A exerts a force on B. Let the force be given by FBA. This is the force exerted on B due to A. In the same way, B exerts a force on A and that is given by FAB. I am showing it as a vector because they have directions. Now, what we can say here is FAB and FBA. They are equal in magnitude, but their directions are opposite. So, a negative sign will come. As you can see, like these are the two forces which are acting on the bodies. One due to the other body, like FAB is the force on A due to the body B and FBA is the force on B due to the body A. Now these two forces, any one of you can consider as to be action, the other one will be the reaction. Like these are the two forces, one can be considered as action, another can be considered as reaction, and their magnitudes are the same. That means we can write here FAB is equal to FBA. But when we put the vector sign, we have to put a negative sign to show that their directions are opposite. So I hope this is clear to you. And one more thing you always remember, whenever action is acting, you cannot say that the reaction will act at a later time. No. Action and reaction acts simultaneously. एक साथ दोनों एक्ट करते हैं. So they act simultaneously, their directions are opposite, their magnitudes are same. Now here in the Newton's third law, when we say that every action there is an equal and opposite reaction, some very important points are there which needs to be clearly understood. Like the first point is, it is applicable, this Newton's third law, it is applicable to all forces. It is irrespective of the nature of the forces. Like we know that the basic forces in nature, whether it is gravitational force or it is weak force or it is electromagnetic force or it is nuclear force. So all the forces, any of the forces you consider, this law is always applicable, Newton's third law. That is, to every action there is an equal and opposite reaction. Any of the forces can be there. Okay? So it doesn't depend on the force, irrespective of the nature of the force. Now the second point is, action and reaction always acts on different bodies. Because if they act on the same body, the net force on the body will be zero and the body will never be accelerated. I am repeating this again. Action and reaction always acts on different bodies, because if they act on the same body, that means same force, magnitude same, in the opposite direction, if they are acting on the same body, the net force on the body will be zero. So therefore there will be no acceleration in the body. Or in the other way, we can consider it as action and reaction cannot cancel each other. Obviously, if they cancel out, because if they act in the same body, then obviously they will cancel each other. So there will not be any acceleration. So they act on different bodies so that they should not be cancelling each other out. Okay. The fourth and another important point is no action can occur in the absence of reaction. I repeat this. No action can occur in the absence of reaction. Now, to understand this, suppose we consider a sports that is a tug of war. Suppose a rope is there. Suppose this is the rope and this is the center point, and two teams are pulling it in the opposite direction. Okay. Suppose one team is pulling in this direction. Now, if there is action, like if it is pulled in this direction and no one is pulling from the other end, so this action will not be there. You cannot have action in the absence of reaction. Okay, like these two forces, action and reaction, are actually will occur, one will occur if there is other. Both will be present together, only one cannot be present. Like simple example, in the tug of war, if one side is free, if this side is free, and if you pull it in from one side, there won't be any reaction. Like if you consider the pulling to be an action, so there cannot be a reaction. Or if you consider the pulling to be a reaction, so there cannot be an action. Okay, so you cannot have any action if there is no reaction, right? So these are the important points which you need to remember all the time. Now, there are some illustrations, that means some examples we are going to consider. So let us see those examples. Suppose here we consider a book kept on a table. Let me draw a table first. Suppose this is the table. Okay, let this be the table. And a book is kept over it. Suppose this is the book which is kept over it. Okay. Now we all know the weight of the book acts in the downward direction. So let W be the weight of the book in the downward direction. But the book will not move in the downward direction because it is kept over the surface of the table. So this is the surface of the table over which the book is kept. Okay. So this surface exerts a reaction force on the book, but in the opposite direction. And this reaction force is exactly equal to the book, weight of the book, so they cancel each other. So we can write here, weight of the book is equal to the reaction force on the book, which is exactly in the opposite direction. We can put a vector sign, so a negative sign can be there, which shows that their directions are opposite. Always remember, a reaction force, sometimes we call it normal reaction. It always acts on a body and it is always perpendicular to the surface on which the body is kept. Like here it is perpendicular to the surface of the table on which the book is kept. So here you can see that again the third law is valid, where the weight of the book is balanced by the reaction force on the book. So that's why the book doesn't move. Now let us take the second example here. While walking, suppose we are walking. Let me draw a diagram. I don't think my diagram will be okay, but suppose a person is walking. Okay, now when the person walks, he applies a force in this direction. Okay, so this is the action. and therefore he gets a reaction force in the opposite direction. This is the reaction force. Okay. Now, if this is the reaction force, this reaction force can be resolved in two directions, one in the forward direction and one in the upward direction. Now, when this angle, suppose this angle is theta, so the reaction force in the forward direction will be r cos theta, and in the upward direction it will be r sin theta. Now, this reaction force is resolved in two directions. This r cos theta is very important, which will make the person to move in the forward direction. This is r cos theta. Whereas the r sin theta will be balanced by the weight of the body. Okay, the person's weight will act in the downward direction, which will cancel this r sin theta. That means r sin theta and w cancels, that is the weight cancels each other, and the r cos theta is responsible for the making the person to move in the forward direction. Okay, so I hope this is clear also. This is all about action and reaction. Okay, so this was the first point we have discussed. This is the second point. Now let us consider the third point. That is, it is difficult to work on sand. Obviously it is difficult to work on sand because when the action will be provided on the sand will move in the direction of action and the reaction force will be very less. So naturally the r cos theta will be very less, and that's why the person will feel difficulty in moving forward. So I hope this is clear to you. And the last point, that is the swimming. While swimming, suppose a person is swimming, this is a person and the person is swimming. This is water. Now what happens? The person moves the hand in the backward direction so that he gets a reaction in the forward direction. This is action of the hand in the backward direction, so he gets a reaction in the forward direction, and that's why he moves in the forward direction. Okay, so this is all about action and reaction, because of which the motion is possible. So I hope the third law of motion is very clear to you. Any doubt in this third law of motion, you can post me the doubt, and you can call me up and you can discuss it telephonically also. So thank you and have a nice day.